Rahul is walking to college after finding his hall ticket. But a thought pops into his head. If any method is an algorithm, does that mean every algorithm is good? Imagine 3 chefs making the exact same dish. One finishes in 10 minutes, one takes 30 minutes, and one completely burns the food. Just because an algorithm produces an answer doesn't mean it's a good one. Today, we'll learn the key characteristics that make an algorithm truly effective. A pizza shop receives an order. 3 delivery boys volunteer. Boy 1 walks. Boy 2 rides a bicycle. And boy 3 takes a motorcycle with GPS. All 3 deliver the pizza. But walking takes 45 minutes, biking takes 20, and the motorcycle takes 10. Would you choose the slowest every time? Of course not. The same idea applies to code. A good algorithm isn't just about getting an answer. It must be clear, reliable, efficient, and guaranteed to finish. First, input. Most algorithms require starting information before they begin. A calculator needs numbers, Google Maps needs a destination, and a search engine needs a keyword. Second, output. Every algorithm must produce a meaningful result. Input goes in, processing happens, output comes out. Without output, there is no solution.
The second characteristic is output. Every algorithm should produce at least one meaningful result, like a calculator showing 42, or maps displaying a route. Now compare that to boil water, add noodles, cook for 2 minutes. These steps are clear and precise. An algorithm must leave zero room for confusion. Fourth, finiteness. An algorithm must always stop after a limited number of steps. Imagine Google Maps telling you, drive straight forever. You'd never arrive.
A good algorithm always finishes. No infinite loops or endless execution. It must eventually stop and provide your answer.
Fifth, effectiveness. Every step must be practical and executable. Math operations are easy for a computer, but instructions like think until you feel lucky are impossible. Sixth, correctness. An algorithm must consistently produce the right result. Would you trust a banking app that miscalculates your balance? Absolutely not.
Seventh, efficiency. Imagine searching for a book. Student A checks random shelves one by one. It works, but it takes 10 exhausting minutes.
Student B uses the catalog terminal and grabs the exact book in 1 minute. Efficiency means solving the problem using minimal time and memory.
To summarize, a good algorithm receives valid input, produces correct output, follows clear and definite steps, and finishes in finite time.
It uses practical operations, guarantees the correct result, and saves time and memory. If even one characteristic is missing, the algorithm fails in the real world.
Now we know what makes a good algorithm, but here's the next challenge. Imagine Rahul choosing between 2 routes, a shorter traffic jam or a longer, clear road.
How do we scientifically compare 2 algorithms to know which is faster? Do we simply click a stopwatch? Or is there a better way?